addition to education, the reserve does tons of research and also conservation and stewardship. And here with us today, we are gifted with Jake Aman, our stewardship director, and he's going to talk to us about planning for sea level rise in coastal habitats. So Jake, go ahead and take it away. Oh, and Jake's going to take questions throughout. He said you don't have to wait till the end. So if you have a burning question, just type it in the chat or raise your hand, or there's few enough of us that we can field those questions throughout. All right, thanks, Jake.
Great. Well, welcome everybody, and thanks, Suzanne. I'm really happy to see so many people here today. We started doing these virtually during the pandemic, and I would say prior to the pandemic, I would usually get 4 people to come to the lab and talk to me about what I do. And now I've got all kinds of people from all over the place, some faces that I recognize, and some folks that I don't know, but welcome everybody. So today I want to talk about just some of the work that's being done here at the Wells Reserve, and it's work that I'm involved with as the director of the stewardship program, but it's also work that many of our partners and community members are involved with. So by no means is this representative of just what I do here. This is what you're going to see today, and what we're going to talk about today is work that's being done by people throughout our region and folks across the state. So I'm going to share a PowerPoint presentation. And like I said, or like Suzanne said, please feel free to raise your hand using the virtual hand raising function. Or if you can't find that for some reason, feel free to just come off mute or type a question in the chat if there's anything you want to ask. And I'm going to run through this presentation, but there's also some interactive work that we could do. There's a couple of online tools that I'm hoping to share today. And if folks have particular areas that they're interested in that we wanted to explore, then by all means, let me know and we can zoom into those areas in the map and talk about what's going on as we go through here. So let me start sharing my screen and we will get going. Okay, hopefully everybody's seeing my screen now. And let's get this slideshow started. Okay, so today we're talking about sea level rise and coastal habitat. And, you know, sea level rise is something I think everybody, oh, Suzanne, what's up?
Jake, yeah, there's, at least on my screen, there are black boxes on the right side and up at the top. Do others see that too? Give a thumbs up.
You know, I just, if anybody is Zoom savvy and knows the solution to this. So on my screen, I have like the little windows with everybody's faces in them. And at the top, there's a little control bar. And I think that's where those black boxes pop up. And I have no idea how to get rid of those, except for maybe to just leave my mouse alone. Maybe they'll go away. So one of them probably just got smaller.
Yeah.
I'm moving one up into the top corner. Yeah, so frustrating. Hold on a second. Let's see here. Hide floating meeting controls. That probably got rid of one.
Yeah, they're kind of moving around. Oh, yeah, now there's just a little one in the right corner. That's
that pesky little
better.
box. How do I get my meeting controls back? Because there was, oh, here we go. Let's see here.
That's a big improvement anyway.
Yeah, sorry about that. I wish I was better at Zoom. And now I've turned on captions somehow. My goodness. Oh, here we go. There it's back. All right, let's see. So we can hide video panel, so that goes away. How about now? How does it look?
Much better.
Okay, I figured it out. Okay. Great. So we're here today to talk about sea level rise and the impacts that it will have on coastal habitat and what people are doing about it, and particularly what we at the Wells Reserve are doing. So first, I'll just note this photograph, which was taken using our drone in 2021. This was during a king tide in November, and we're looking at the Webb Hannet Marsh and estuary. Looking south, you can see Mount Agamemnicus in the distance. But one thing that I think is really notable here, if you're familiar with the marsh, is it's missing. Basically it's underwater here. So we had a really high tide, and I just really like this picture, number one, just because it looks so different from what we're used to looking at, but it also provides a little preview of what we're going to see going forward as sea level rise continues apace, and this will become more and more normal. The other thing I like about this photo is that it really demonstrates one of the issues that we see on our landscape in tidal marshes where we have road building. And if you can see in the bottom right-hand corner of this screen, you can see Drake's Island Road, and there's a tide gate there, which you can just barely make out. And you'll notice that the marsh on the north side, closest to us, on the bottom of the screen, is not covered with water. But one interesting thing to note is that that marsh is actually lower in elevation than the rest of the Webhanet Marsh by at least a couple feet. So what we're seeing here is the effects of a tidal restriction, in this case, the road and the culvert. So this photo just really illustrates how tidal road crossings and tidal restrictions impact the functioning of our marsh systems. And we'll get into that more a little bit in a moment. Okay. Can I advance slides? Oh, there we go. Okay, so I think probably everyone's familiar with the Wells Reserve, but here's our lovely site. And just want to remind everyone, our mission is to understand and protect and to restore coastal ecosystems in the Gulf of Maine. And we do that with research, stewardship, and education programs, as well as by working with the communities where we live. So today, in Maine right now, we have significant momentum around addressing not only sea level rise, but other effects of climate change. And a lot of that is coming from the Maine Climate Action Plan, which was released in 2020 and was the culmination of a lot of work by scientists and business people and community members and all sorts of folks from different walks of life throughout Maine that came together to develop this comprehensive plan for how to address climate change and to understand what those impacts are going to be in the future. And this document is being updated. They've released, I think, several updates over the last couple of years, particularly around the science, what we understand about climate change and sea level rise. And this document is providing the impetus for a lot of the work that is going on right now in our coastal areas. So I just wanted to highlight the Maine Won't Wait Climate Action Plan. It's a really great document if you have some time, if you haven't seen it before, to dig in. It really provides, I think, a lot of hope for how Maine is going to address climate change in the future. So today we're specifically talking about sea level rise. You've probably, if you know anything about sea level rise in Maine, you've probably seen this graph before. This was put together by Pete Slavinsky at the Maine Geological Survey. And this is based on predictions for the Portland, Maine tide gauge. And this shows a variety of scenarios for sea level rise. Each one of these colored lines shows a different scenario, from the extreme scenario in red to the low scenario in dark blue and everything in between. And these scenarios are based on different, what they call carbon pathways. So different essentially how much greenhouse gases are going to go into the atmosphere. And it really depends on what we human beings end up doing. And so the Maine Won't Wait Climate Action Plan really targets that middle line, the dark green line, which you can see there, 3.9 feet of sea level rise by 2100. And so that's kind of the range that we're thinking about in terms of the work that we're doing. There are potentially reasons to think about higher levels of sea level rise. And it just kind of varies from site to site and the types of things that you're thinking about. This chart is from the Science and Technical Subcommittee update that was released in 2021. And I'm just highlighting here sea level rise, a monthly sea level that's been recorded at a number of different tide gauges along the main coast, and I'm highlighting the Wells tide gauge here at Wells Harbor, which you can see in this photo. And this is just showing record sea level, record water levels, excuse me, the highest water levels recorded for each of these months during the life of these tide gauges. So in Wells, our tide gauge has been at the harbor since 2005. And in 2021, we saw 4 of the highest water levels for those months recorded. So, and you can see now our tide gauge has only been there since 2005. So of course, a lot of the records are more recent, but you can look at the Portland tide gauge, which is the oldest one in our state, going back to 1912. And you can see there also that most of the records for highest water level are occurring within the last couple of years. So obviously this problem, sea level rise is happening. We're seeing increases in more recent timescales. And so it's a really pressing problem that we need to start addressing. So what is sea level rise going to look like on the landscape? So this is a screenshot from a sea level rise and storm surge map viewer that the Maine Geological Survey has on their website. This is the Wells Reserve and the upper Webb-Hannett River. The blue here is the current extent of the highest annual tide, so once a year, that king tide. And then the green, the dark green and the light green show the 1.6 and the 3.9 foot sea level rise scenarios. Under that intermediate sea level rise scenario, the dark green here, you can see that it's 3.9 feet expected by 2100, but at 2050, which was the halfway point from 2000 which was when these predictions were started, you can see that the expected height is about 1.6 feet. So we're showing those 2 scenarios here. So a lot of the landscape that's not currently experiencing annual flooding we'll start to see more and more of that as time goes on. And you can see that obviously that's occurring in some of the undeveloped natural areas here at the reserve at the top of the screen, but that's also occurring in some of the highly developed areas at Drake's Island and other areas along the shoreline. And that's going to be a big problem going forward. So just to highlight some of this, a more recent example, most of us were probably, if we weren't in Maine, at least you probably heard about the holiday storm on December 23rd last year. And this is tide data from the Portland tide gauge showing the peak water levels that occurred during that storm. And so at Portland, they recorded an 8.4 foot water level. And the predicted water level without a storm would have been around 6 feet. So they had about a 2.5 foot storm surge associated with that event, which is pretty large. And that water level with 2 feet of sea level rise would occur approximately once per year, or about a 99% probability that we would have an 8.4 foot water elevation. So that will essentially become the highest annual tide conditions with 2 feet of sea level rise. So what does that look like on the landscape? So this is a picture of Sawyer Road in Cape Elizabeth and looking south to Scarborough. The Spurwink River runs through the middle here under a culvert, which you can't see, and it forms the border between the 2 towns. This photo was taken by my colleague at the Casco Bay Estuary Partnership, Matt Craig. And wow, what a photo. I mean, there's about a 1/4 mile of road that crosses the salt marsh here. It's very low elevation. We've seen it over top in storms previously, but nothing like this before. I mean, this is just so dramatic. You know, that's several feet probably deep at the lowest point there. Again, this is what we might expect to see at least once a year with 2 feet of sea level. And that would just be under normal high tide conditions. So there's really some dramatic changes that are coming. And, obviously, you look at this and you think, well, that's, the impact there is that people aren't going to be able to drive across that road and that it will probably start to erode and deteriorate. But the other thing that we're looking at here is a completely inundated marsh. Both sides of this road are salt marsh. A lot of that has been heavily impacted by human activity over the course of the last few hundred years, farming and ditching. And that increased inundation is going to potentially have very negative effects for our coastal habitat, for our tidal wetlands. Even though those tidal wetlands are adapted to tolerate daily flooding or monthly flooding, with sea level rise, they're going to be experiencing that flooding more and more. And those plants that make up the salt marsh can only tolerate so much flooding. And so we're going to start to see dramatic changes in our salt marshes as this tidal inundation increases, unless potentially we can make some changes and allow the functioning of the marsh to go to what it's supposed to do. But even then, the changes may be too rapid to adapt to so much change over time. And so let's talk about some of the impacts for coastal habitat from sea level rise. We could expect to see increasing erosion rates for our shorelines. So our sand dunes and our beaches will experience more erosion than, even though they've already been experiencing a lot of erosion. I'm sure most of you know about that. We're going to start to see that more and more, particularly at locations where there's development that directly abuts the beaches and the dunes. We're fortunate at the Wells Reserve. We have a stretch of Lodholm Beach that is undeveloped, and the beach and the dunes are bordered by salt marsh and a little bit of forest habitat. And over time, with sea level rise, we'd expect to see the sand getting pushed further inland and the beach to move. And so we're really interested to see over time how that takes place. I didn't include a picture of it today, but we, after the holiday storm in March of this year, we got out and flew with our drone and collected some aerial imagery of the beach. And we saw a significant overwash of the dunes, lots of cobblestones and sand thrown up into the vegetation all the way up to the tree line. So, we can see that process starting to take place already, with sand being scoured off the beaches and thrown up into the dune system. So over time at Lodholm, we expect to see the sand dune and the beach migrate inland and hopefully sustain itself over time. But in those places where there isn't a natural dune system and there isn't a back barrier wetland, we may see a total loss of our sand beaches and our dunes. And that's going to have really negative impacts for the species that depend on that habitat. In particular, we have this cute little fluffball here, our piping plover, which is an endangered species, and makes its home at Lodholm Beach and other beaches in southern and mid-coast Maine. So it's not just impacts to the physical habitat, but it's also impacts to the wildlife species that depend on them. In our salt marshes, we could expect to see increased rates of shoreline erosion and drowning of the salt marsh vegetation and conversion to mudflat. And I was actually on a meeting just yesterday where they were talking about this potential impacts of sea level rise on tidal mudflats, which is a totally new topic to me. So I decided to throw that in here. So we could expect to see even our tidal mudflats start to experience some impacts with the loss of the finer sediment that clams like to occupy. We could see some of those shellfish species and others that depend on that habitat seeing some impacts. So we'll expect to see loss of habitat and impacts on our wildlife, as well as the introduction of non-native species, which we've already been seeing in our coastal areas. But we could start to see new species arriving as ocean currents change, as our ocean temperatures change. We're already seeing new species coming to our marshes. We've been monitoring for the last couple of years the arrival of blue crabs in the Webb Hannet Marsh, a species that's native to North America, but occurs usually south of Cape Cod. And we're now starting to see them somewhat regularly in Maine. And our researchers here who are tracking the blue crab have actually tagged a number of those crabs, and they found a crab this year that they had tagged last year. So what that means is that these species are finding it more hospitable in our marshes and our estuaries and are actually staying over winter, which is really interesting. And we hope to learn more about that in the coming years. And among other impacts, the last one I'll just mention is potential contamination from upland sources. So we're going to see flooding in developed areas. That's going to be washing a lot of contaminants off of the landscape and into our estuaries and our coastal areas. So something that we need to start planning for going forward. So what are some of those impacts going to look like on the landscape? Here's some more aftermath from the holiday storm. This is Ferry Beach State Park in Saco. And I think the last time I had been to the beach here, these dead pine trees were right at the edge of the sand dunes. And so you can really see how dramatic that coastal storm was for the dune here. And what you can't see is a significant amount of sand that was pushed back into this forested area. But these trees can only tolerate so much salt water. And the ones on the front line here have already succumbed to increasing sea level and storms. And this is just more of what we're going to see as time goes by. We're going to see more of these trees dying and the sand dune migrating inland. This is that same culvert in Cape Elizabeth. This is a shot looking through it on the upstream side. And what I'm highlighting here is this massive scour pool that has been eroding away at this marsh. And this is one of the types of impacts that we see from these undersized culverts, where we're trying to push a massive volume of water through a tiny little opening that causes really high velocities, which causes scouring and degradation of our marshes. And this photo also just highlights the issue with tidal restrictions, where you have this massive amount of water that needs to move upstream into the upstream marsh, and it's all having to go through this culvert, except when the road overtops, of course. So it's another interesting impact that we're going to see from increasing sea levels in these larger storms, is that we're actually going to see some sort of de facto salt marsh restoration happening in real time as these areas become increasingly flooded on a regular basis, unless, of course, there's something done to the roadways. So I'm going to move on from talking about. Let's see if I can get this to go away again.
Jake, we have a couple questions in the chat. Is this a good
Oh,
time
great.
to?
Yes, please.
Yeah.
I can't see anybody, so let me know.
Yeah, so the first is, can you talk about the impacts to septic systems and what we should do about it now? And then the second is the soil in Maine conducive to sunny day flooding like Florida?
Okay, well, let me tackle the first one, and then I need some clarification on the second one. So yeah, so septic tanks, I mean, if they're going to be getting flooded, I'm not an expert on this, but yeah, saltwater intrusion into the groundwater, I think, could potentially start to have a negative impact. I mean, I don't know how rapidly a septic tank could deteriorate when it's exposed to salt water. I know that some concretes are not made for salt water, and of course, if the salt water is getting into the septic tanks, then obviously that's a big issue, because we'd start to see that untreated waste starting to flow into our estuaries and our rivers. So certainly that would potentially be a concern if they're in the affected areas. And then the second question, I'm not quite sure I understand what's meant by soils that are conducive to sunny day flooding. So maybe whoever answered the question, could come off mute and just clarify what they mean by that.
And there's a second part now. It says the underlying rock in a lot of Florida is very porous, so the sea level rise is already coming up through the ground.
Oh, okay, sure. Yeah, that's an interesting question. I mean, I know saltwater intrusion is an issue in Maine, and it's a concern particularly for people that have groundwater, like dug wells, as their drinking water source. So, I don't know specifically how the different soil types would affect that. We have, in our coastal areas, we have a lot of clay, we have a lot of sand. So, I'm not 100% sure the answer to that question, but I think it is an issue that people that live near those coastal areas need to be concerned about. Did that answer folks' questions?
Hi, this is Kiki Tidwell. I was the person who asked the question. I'm in a subdivision where we have septics and wells, and we're right on the ocean. And I'm worried about a stew of septic and well water with sea level rise. And I've also really highly recommend the podcast, How We Survive, which talks about what's happening in Florida with sea level rise. And that's why I'm concerned about sunny day flooding.
Yeah, and for folks that aren't familiar with that term, sunny day flooding is just flooding that occurs, without a storm. So, we're seeing more and more of that sunny day flooding with increases in sea level, and it's a real issue for folks that are located adjacent to those tidal areas, and it's going to be a real problem. So yeah, I think I wish I could point you to some better resources to answer that particular subject right now, but maybe I can send Suzanne some information and she could pass that along. Okay, any more questions right now, Suzanne?
No, I don't see any.
Okay. All right. Well, if anybody thinks of anything else, please chime in. I'm going to move on now to start talking about some of the work that we're doing at the Wells Reserve to understand the changes that are coming related to these coastal flood hazards, and talk a little bit about what we're doing in our communities to address those changes. So the first project I'm going to talk about is called Climate Ready Coast Southern Maine, and it's a multi-year project that was funded through the National Coastal Resilience Fund. It's being led by the Southern Maine Planning and Development Commission, supported by Wells Reserve, Maine Sea Grant, and the 10 Southern Maine communities between Kittery and Scarborough. And the ultimate objective of the project is to develop a coastal resilience plan that addresses coastal flood hazards in these communities, and to better prepare these communities to meet these challenges that are coming from increased flooding in their coastal areas. This project is in its second year. We've undergone a number of different phases. I'm not sure if I have that on the slide here. Yeah, I'll just skip ahead here. So it's focused primarily on, really focused on municipal needs and supporting municipal partners and community partners. It's also looking at not just infrastructure, but natural habitat that occurs in these communities and the benefits that that we see from those natural areas. And the plan will also propose what are called nature-based solutions to addressing those coastal hazards. So that's a little bit of jargon, but essentially it means finding not just hard, what we call gray engineered solutions. So we think typically when we're trying to protect our coastal areas from flooding, we think about big concrete and stone seawalls and really hardening our shoreline. And what we found over time is that the hardening of our shorelines actually exacerbates the erosion problems in a lot of cases. And so there are softer approaches, if you will, that integrate natural features like vegetation that can still help absorb the impacts of the waves and the flooding in those areas, but also provide habitat and don't further exacerbate the problem. So while we recognize that there will be a need for hard engineered solutions in many of these areas to protect critical assets and infrastructure, we're trying to promote the idea that these nature-based solutions could offer some beneficial ways to address these coastal flood hazards. So one of the first things that we did in this project was to conduct a vulnerability assessment using GIS data, so spatial data that was publicly available for the region. And there's a lot of data available. We have data on sea level rise and coastal storm hazards. We have data on coastal habitat. roads, buildings, development, and a range of other things. And we sort of put all that into the map and then looked at areas where those coastal hazards were overlapping with those natural and built assets. And there's a great online map viewer, which I'd be happy to share, and we could explore a little bit today if there's areas that people are interested in. But it allows you to go in and turn these layers on and off, look at the impacts of these coastal flood hazards in different areas. And it uses color coding to show the degree of impact. So we actually used a scoring system that showed essentially when an asset was going to be impacted by one or more of those coastal flood hazards, and also the significance or the importance of that particular asset. So in this middle screenshot here with the different shades of green, this is showing different natural resources in the area of Pine Point and Scarborough. And the darker green denotes higher habitat values, which is essentially more things going on there, more layers that are overlapping. So it might be salt marsh habitat, it might be tidal wading bird and waterfowl habitat, it might be rare and exemplary plant communities, and so on and so forth. So where you see the lighter green, there's less going on. Where you see the darker green, there's a little bit more going on. So this was a way to sort of not only highlight where the coastal hazards are having an impact, but also potentially the importance or the significance of those assets that are being impacted to the community. And all of this information, there's a lot that goes into this. All of this is allowing the working group, the 10 communities, to focus their efforts because this is a widespread problem. There's a lot going on, particularly in some of these low-lying areas around Scarborough Marsh and the Webb Hanna Estuary and other places where we have these big barrier dune systems that have been developed in these large salt marsh systems. There's a lot going on, and unfortunately, it won't be possible to really do everything everywhere. So we need a way to really focus efforts, at least in the near term, to start making some decisions about how we're going to address these coastal flood hazards. So that's what this mapping tool is really for, is just to help sort of identify where some of the real problem areas are and get the conversation started about what communities can do in these areas. Another thing that this map data is only as good. It's only as good as the data that we put into it. There's a lot of gaps. There's a lot of information that we don't have in map form. We don't have spatial data sets for a lot of things that are important to the communities. And that's why we've got this black box here in the heading. So there's a lot of information, but what do you do with that, and what's missing from there? How do you turn this into something that's meaningful for the communities? And there's different users for this data and for these tools, and they're going to have different objectives. So how do we really drill down and figure out what's important on a regional basis? And so the next step for the project was to take all of that data and take that mapping tool and use it to convene the working group from these 10 communities, which included municipal officials, community members, partners at regional conservation and public safety organizations, and bringing them together. We held an in-person workshop last fall in October 2022. And we sat down and we looked at these maps and we looked at these locations that have a high concentration of exposure to these flood hazards. And we worked through the list and we identified a shorter list of 15 priority vulnerable areas that we would move on to the next phase of the project. Now we identified over 50 areas, and there's really more than that had a real high concentration of exposure of exposed assets. But just due to budget limitations and the amount of time allotted for this project, we really needed to narrow it down to 15 areas that would be highlighted in the Coastal Resilience Plan. And so because we needed to narrow it down, we wanted to make sure that these 15 areas were representative of the types of impacts that we're seeing across the region, so that we could show how those types of impacts could be addressed. And then that could be used then to transfer to other locations that are experiencing similar impacts to similar assets, so that a community that didn't have one of their sites highlighted in the plan would still have an idea about where to start addressing some of these issues. So, so we hosted this workshop in October. We drilled down to those 15 priority sites. And then the next step for the project is that we're working with a consultant to develop visual renderings of some of the nature-based solutions that could be applied in these priority areas to start addressing the impacts of coastal flooding. And so that's where we're at now with the project. And that's going to sort of the visual rendering part is going to start to wrap up here pretty soon. And then we'll be moving into the phase where we're actually writing the coastal resilience plan with these 10 communities. So the plan will be hopefully, I think, coming out in the fall of this year. And that's not the end. We're already working with these communities to start filling the information gaps that we identified during this project, to start teeing up some of these really high priority areas for funding, so we can start doing some of the work on the ground that's needed to address coastal flooding in these areas. And that's the part that I think is really exciting. This plan is just a tool for these communities to start making decisions. The really exciting part is going to see how they start using it over the course of the next, decade or so. Excuse me. So I'll just end.
Jake,
Yeah, go ahead.
oh, sorry, excuse me. There's interest in knowing what are the 10 communities or 15 vulnerable areas.
Yeah. Oh, I should have anticipated that question. Well, the 10 communities are Kittery, York, Ogunquit, Wells, Kennebunkport, Biddeford, Saco, Old Orchard Beach, and Scarborough. Don't think I missed any there. And then the 15 areas, let's see if I can do this just off I'm going to try off the top of my head. I don't have the list in front of me, but we identified Seavey Island and can't remember which gate it is, but one of the gates to the Portsmouth Naval Shipyard in Kittery. We identified Long Sands Beach in York, Perkins Cove, and the Ogunquit Beach parking lot, two different vulnerability hotspots in Ogunquit, Mile Road and Casino Square area in Wells, the Kennebunk Lower Village and Kennebunkport on the Kennebunk River, Fortunes Rocks Beach and Mile Stretch Road and Biddeford Pool, as well as Biddeford Saco downtown in the Mill area, Ocean Park and Goosefair Brook in Old Orchard Beach and Saco, East Grand Beach and Jones Creek Marsh in Scarborough and Old Orchard Beach, Route 1 across the Scarborough Marsh at the Dunstan River crossing, and I think I'm forgetting one. I haven't been counting them in my head.
That's pretty
yeah,
good.
Yeah. Those are the ones I can remember. There's lots of others, but those are the ones that are getting highlighted for these visual renderings.
And Jake, Steve has his hand raised. Go ahead, Steve.
Thanks very much. Jake, I have a kind of a big picture question. I do have a background related to climate change. And one of the things, the context for my question is, over the past several decades, almost all of the projections by the IPCC and other related institutions, the effects of climate change have been more accelerated than their projections. So that's the context. But my question is, in the battle between hardened solutions and nature-based solutions, species don't vote. People vote. And it leads me to believe that what we're going to wind up with, because of what we're seeing in other parts of the country, is a kind of dedication to using our resources for hardened solutions rather than nature-based solutions. Can you comment on that, the trade-offs, and whether you see there really is a chance for nature-based solutions?
Yeah, that's a good question. Well, one thing, so in terms of the trade-offs, I mean, I think, number one is these hardened engineered solutions are often more expensive. And they do, in a lot of cases, tend to exacerbate the problem. So for example, with our sandy beaches, we're seeing those areas that have hardened shorelines adjacent to the beach that are there to protect roads and homes. Those are the areas where we see the most concentrated erosion of our beaches. And the few areas that are not developed, we're not seeing that same loss of sand over time. We're still seeing an impact, but that sand is moving and it's staying in the area. So at Lodholm Beach, for example, we have experienced a lot of sand that's being lost in the offshore and the nearshore area of the intertidal part of the beach. But we're seeing that sand getting thrown up into the dunes, and we're seeing the mouth of the river changing and adapting. So I think the trade-offs are, there's multiple trade-offs there. However, there are some areas that are just so built up and maybe don't have as much in terms of natural resources going on that maybe a hardened solution really is okay there. If that's what the community chooses to prioritize. And I guess I want to just emphasize that, you're right. Nature doesn't vote, animals don't vote, but people in these communities really are concerned about their natural resources. And so as these decisions are being made, I think the best that we can do, from a scientific community, is to make sure that these communities are armed with the best information that they can possibly get. As far as the long-term viability of nature-based solutions, I think, there's a lot of lessons that have been learned from other parts of the country, further south along the Atlantic coast. In Maine, these nature-based solutions are a little less tested. That's something that I'm learning as these projects progress. And so I think we need more information. We need to try them out in different areas, and we need to see how they work. One thing I will say that nature-based solutions have going for them is that there's funding available to do these types of projects. So the National Coastal Resilience Fund, which is a program funded through the National Fish and Wildlife Foundation, heavily emphasizes nature-based solutions. So we're seeing that there is support, sort of from the top level with the federal government and funding behind it, and also from the grassroots, from our communities who want to see our natural resources protected. So I think there's reason to be hopeful, but I think that there's a lot of questions that remain, and we need to do more work to understand, what the impacts of these coastal hazards are going to be, and whether or not we're going to be able to we're certainly not going to be able to protect everything everywhere. I think that's just something we have to accept. There's going to be losses, and there's going to be changes. And we have to do our best to adapt to those things. We're not going to be able to just hold the line. So I hope does that answer your question?
Yeah, thank you very much.
Yeah, my pleasure.
And Jake, I'll just say there is some interest in seeing the mapping tool, the mapping view. And then there's just one other question in the chat, which relates to what you were just talking about. Long Sands has already installed an extensive built seawall structure. What else can it do?
Yeah. So Long Sands, I'm glad somebody asked that question. So York installed this really interesting stepped seawall. And my understanding is that that design really helps to alleviate the wave energy at the foot of that seawall, and can hopefully help to keep some of that sand in place over time. Beyond that, so the town of Saco, and particularly the community of Camp Ellis, has been looking into the use of wave attenuation devices. So these are structures that are placed offshore that break up wave energy and allow sand to accumulate between them and the shoreline. And I attended a presentation last year by the engineering firm that was hired to do a study of the feasibility of these devices for Camp Ellis, and it seemed promising. So again, Maine is a unique part of the coastline. What works well in other areas may or may not work well here. We have bigger tides, we have ice, we have these big northeaster storms. So I'm not sure. And these wave attenuation devices are massive concrete. They look like pyramids essentially that get dropped into the water line. So are people going to want to see those when they look out their window? Maybe, if it means that the coastal areas are being more protected. And also the question is how long are any of these solutions going to work? I mean, maybe they'll work for the short term, maybe, for 1 foot or 2 foot of sea level rise, but are they still going to be working in 80 years when we get to that 4 foot, potentially get to that 4 foot sea level rise scenario? I don't think that's a question that anybody can answer. So yes, Long Sands Beach, they have a solution for the short term. What are they going to do for the long term? We're going to kind of have to wait and see how that seawall does, and we'll probably have to continue to adapt. None of these strategies are permanent solutions. And hand in hand with this this coastal adaptation is we need to stop putting greenhouse gases into our atmosphere and slow down the rate of change. And that's not a problem that Maine alone can solve, but that's definitely another part of what our communities can do to help work on this problem as part of the global community, is to reduce our greenhouse gas emissions. I wish I had something more hopeful to tell you about Long Sands Beach, but it's not unique to York. And I was thinking today, I'm wondering if other places will start to look at that same seawall structure now that it's been there for a little while, and we can see how it's doing. We have volunteers that collect data at Long Sands Beach, and Maine Geological Survey takes that data and produces a report on the beaches every year. I haven't looked at the beaches report in a while. It would be interesting to ask the geologists at Maine Geological Survey how that beach is doing now that that seawall is in place.
Just to follow up on that, what are the considerations for a wave attenuation device offshore? I would imagine there might be groups that would not want it, like surfers or fishermen who lobster that habitats. What are the considerations?
Yeah, well, I think you certainly named some of the considerations. I mean, there's protecting coastal property, I think, is probably one of the top priorities for these communities. But there are other uses in those near shore areas. So that has to be looked at on a case by case basis. I mean, if there's other uses like commercial fishing in those areas, then there needs to be a community dialogue about what to do. I don't think those types of projects can go forward unless there is an open dialogue with all of the stakeholders present and weighing in with their concerns and their needs. But I think that there will be, I don't want to use the term winners and losers, but I think there will be trade-offs, and that's going to be one of the challenges. I mean, look at this map. I mean, these homes, these developed areas on these barrier dune systems, if I lived there, I would be really, really concerned about the future of my home. It's just not feasible to think that we're going to build some type of a levee to keep the ocean out of these areas. There's flooding from the ocean side, but there's also flooding from the marsh side. So I think communities are going to have to start making really tough decisions, and I think some people are going to be unhappy about those decisions, and that's unfortunate. But we're facing really dramatic changes in these coastal areas. Did that answer your question?
It did. I guess I'm just wondering where there are more examples of where these wave attenuation devices have been installed, and if there's any track record of what the effects are, though.
Yep, they certainly have been used in other parts of the country. I think the engineer that they hired to do this study was from, I want to say, Georgia. So further down the coast, these types of solutions are being used. They don't have as big tidal ranges there, so it's a little bit easier, I think, to design these things and install them than it's going to be here in Maine. You know, if you only have a 3 or 4 foot tidal range, then obviously, you know, the waves are not going to be as big, or at different elevations, where here we have, you know, a 10, 11 foot tide range at times. You're going to need a much bigger device, a much bigger wave attenuation device so that it can work, you know, at those higher tide elevations. But there are examples. I don't have one that I can give you specifically, but this technology is being used in other parts of the country. Maine is really learning a lot from what other folks are doing in other parts of the country. Okay, well, we're actually getting close to the end of the hour, which I'm always surprised that I can talk for a whole hour. I want to just highlight one other project real quickly, and then we can take a couple last questions if there are any. I guess we probably don't have time to get into this map viewer, but I encourage you to go on to the Southern Maine Planning and Development Commission website. They have, I think it's actually probably even linked on the Wells Reserve website as well. I'm sorry, I don't have that link to share with you right now. And you can get into that map viewer through your web browser, and you can turn these layers on and off, and you can explore the coastline and see what these coastal hazards, you know, look like in different areas. So the last project that I want to touch on very quickly is called Coastwise, and Coastwise is a set of best practices that have been developed over the last couple of years through a really great partnership of agencies and natural resource partners and organizations, as well as the engineering community and the municipal, some municipal representatives as well. And Coastwise is designed to address the impacts of tidal restrictions, roads, road bridges, and culverts in the tidal environment. It includes, it's a holistic set of best practices that can guide a community from you know, all the way through the design and construction of one of these crossings from start to finish. So I mentioned, you know, the tidal crossings in coastal Maine are ubiquitous. We have thousands of them in the state of Maine, either current tidal restrictions or ones that will be tidal restrictions in the future. All of them, for the most part, I shouldn't say all, but most of them have been mapped by the Maine Coastal Program. And there's another online viewer called the Maine Tidal Restriction Atlas that you can go online and find, I think fairly easily. We have a link to it on our website as well. And you can see where these structures exist. And if you click on these little dots, you get a little bit of information about them. Sometimes they even have photos if those are available. This is a list of the partners that have helped develop these best practices. So we've really had a lot of great input and expertise that has gone into this. And the target audience for these guidelines are really municipal road owners, the engineering community, and partner organizations that are working to restore coastal habitat and improve coastal resilience in our coastal communities. So just to highlight what the impact of these tidal restrictions are, we've got 3 different crossings here, sort of illustrated in these diagrams, and then we've got what we call a hydrograph, which just shows the tidal elevation changing over the course of an incoming and outgoing tide. And under the top example there, the unrestricted crossing, you can see that the seaward and the inland side, the red and blue lines more or less match. So the tide comes in, water level goes up, tide goes out, water level goes down, and that's more or less matched on the upstream and the downstream side. But as the crossing opening, that open area of that structure gets smaller and smaller relative to the tide volume, you start to see that upstream side, the red line, starts to become muted and eventually becomes much smaller than that downstream side. And that's just showing the impact of that restriction, not allowing that tidal flow to get upstream, which has a really negative impact on our tidal salt marshes. So this information is compiled in a manual that's going to be released soon. Oh gosh, I hope so soon. We've been working on some revisions over the last couple months. It's almost ready to come out, hopefully this year. I know it says April 2023 here. It's not going to be April 2023, but hopefully May. There's a companion study that's being completed by the Woods Hole Group, engineers down in Massachusetts, looking at different types of modeling that can be used to design these structures and to evaluate their performance under sea level rise, different sea level rise scenarios. Once that study is completed, we'll be releasing a supplement to the Coastwise manual, which will hopefully provide a little bit more detailed guidance for folks that are doing this type of engineering on sort of hopefully simplified principles for how to design these crossings. These are really complicated projects and it takes really specialized knowledge. And so we're trying to sort of simplify it and make it as accessible as possible. And I mentioned sea level rise. That's a major consideration for Coastwise. These structures are often in place for 70, 80, even 100 years sometimes. And there's going to be a lot of changes that occur during that time, particularly with sea level rise. So it's really critical that when road owners are looking to replace these structures, that they're thinking not only about the conditions that exist today, but also about what those conditions are going to look like in the future. And I just have a couple examples here of some coastwise crossings. So this is a crossing down in York that was upgraded in 2018. The town got a grant through the Maine DEP and upgraded this little metal culvert into this nice big open bottom structure that you see here on the right. And then this past year, we worked with the town of Cape Elizabeth to upgrade a crossing that was actually carrying their two main sewer lines for the town. You can see those in the right-hand picture. There's a green pipe going across the top of the structure there. So this was a really critical project for the town. This is in the Spurwink Marsh. And so they upgraded from these two deteriorated metal pipes to this concrete structure. Now, this is an example of a project where some accommodations had to be made. The structure is not exactly the way we would have liked to see it, but because of those sewer mains, unfortunately, we had to make some accommodations. But this is a much better crossing than what was there before, and we expect it to perform fairly well under the 3.9-foot sea level rise scenario. And then I'll just finish up by highlighting again the Maine Tidal Restriction Atlas. This is an online map viewer that you can go and find tidal restrictions in your area. If you know of a bridge or a culvert in your area and you're wondering whether or not it restricts the tides, you can use this map to go explore that area.